If you're paying a virtual assistant $1,000 a month to manually move data, you're taking a crisp check and tearing it in half. Standard cloud automations charge by the task or the token. For a high-volume business, this creates a monthly bill that grows linearly with your success, eating into the profit margins you were trying to protect. Today, we are going to build an alternative. I'm going to show you how to construct an AI employee architecture that runs entirely on your own local hardware. It operates completely privately and costs exactly $0 to run, no matter how many tasks you throw at it. Step 1 is gathering our tools. To build this local stack, you only need 2 prerequisites: Docker Desktop, which lets us run isolated software containers, and a free Cloudflare account to handle our networking. By setting up this specific self-hosted architecture, you cap your costs at 0. You can scale your AI operations and process millions of data points without adding a single cent to your monthly overhead. We'll start by giving your new automation stack a brain. To do that, we need to open up your computer's terminal, the foundational command line where we will install our local intelligence layer. Looking at this terminal interface, you'll want to type Ollama run Llama 3 and hit enter. This command downloads Ollama and immediately spins up the world-class Llama 3 model on your machine. Send it a quick test prompt to verify it's working. If your computer's cooling fans suddenly spin up and get loud, don't worry. That physical noise means your local hardware is actively processing the data. Your intelligence layer is now fully operational and secured on your device. You are completely disconnected from external APIs, and those token costs are gone. Now that we have a brain, we need to build the nervous system to route your business data to it. For that, we use an open-source workflow engine called N8N. In this split-screen view, you can see how we launch it. Run the Docker container command, and you'll see your container activate on the left, while your brand new N8N workflow dashboard loads locally in your web browser on the right. If that dashboard doesn't load immediately, you likely have a port conflict. Check your Docker container logs to see if another application is already using that network port and adjust it accordingly. At this point, your internal logic engine is alive. However, it's completely isolated on your computer. To actually automate tasks from platforms like Gmail or Stripe, we need to build a secure bridge to the outside world. Here is the central challenge. You need external apps to trigger your local N8N workflows, but opening up your home or office network directly to the public internet introduces security risks. External data hits a solid firewall. To bypass it safely, we use a Cloudflare tunnel. This outgoing connection avoids opening vulnerable ports. Configure a public domain in your dashboard to route through this tunnel directly to your local port. To verify your setup, disconnect your computer from its local Wi-Fi and pull up your new public URL on a separate mobile network. If the N8N dashboard loads, your tunnel is active. It is crucial to use this specific tunneling method. Manually port forwarding your local router leaves your entire network exposed to automated attacks. This tunnel enables your local hardware to receive triggers from services anywhere in the world, while keeping your internal network invisible to public traffic. Let's put these pieces together. Open up your N8N visual canvas. This is the workspace where we will assemble our local components and build a live workflow. This interface shows our first step, placing a webhook node onto the canvas. Set the method to post so it acts as an open listener, ready to catch incoming data from your external tools. Next, drag out an Ollama node. Simply click and drag a connecting line from the output of your webhook node directly into the input of your Ollama node. You then configure the Ollama node by successfully mapping the dynamic text payload from the webhook into the prompt field. This tells your local AI exactly what text to read and process. To run our first integration test, send a sample message from an external mock platform straight to your webhook URL. In our flowchart, the data packet hits the webhook node, turning it bright green. The payload flows into the Ollama node. Your local AI analyzes it entirely on your own device, never sending a single byte to the cloud. Within seconds, the Ollama node finishes its task and outputs the summarized, categorized, or processed text directly back onto your N8N canvas. That completed execution confirms that you have successfully built a fully functional, entirely zero-cost automated data processing pipeline. The blinking lights on the server rack represent a fully functioning on-site intelligence center. By running these models locally, you have converted your existing hardware into a permanent business asset. We use this exact stack at Westwork Studios to handle client onboarding. What used to take 4 hours of manual data entry now takes 30 seconds of AI processing, and the cost per run is zero. You can take this foundational pipeline and expand it. Connect it to your CRM, your customer support inboxes, or your team's Slack channels to handle repetitive tasks that were previously too expensive or too sensitive for cloud-based AI. Owning your AI infrastructure means your operating costs stay at zero, even as you automate more complex, high-frequency tasks. This ensures your profit margins stay protected as you scale. If you want us to custom build a data engine for your business, visit westworkstudios.com.